Hello everyone, I'm Professor Roxana Ezenekwe, and welcome back. Today we're diving into one of the most important foundations in statistics, inferential statistics, specifically confidence intervals and hypothesis testing. If you've ever wondered, how do we make decisions about a population using only a sample? How do we know our estimate is reliable? How do we test ideas or claims using data? You are in the right place. Let's begin. Inferential statistics allows us to use information from a sample to make conclusions about a population. Because we rarely collect data from an entire population, we rely on 1. Estimation, using sample data to estimate population parameters. Hypothesis testing, using sample data to test claims. Everything we cover today falls under one of those two branches. A confidence interval tells us how confident we are that the true population parameter lies within a certain range. For example, a 95% confidence interval doesn't mean there's a 95% chance the population mean is inside the interval. Instead, it means that if we repeated the sampling process many times, 95% of the intervals we create will contain the true mean. Suppose we take a sample of 40 students and find an average test score of 78, with a standard deviation of 10. If we construct a 95% confidence interval, we might get something like 78 plus 3.1 SACS 74.9, 81.1. This means we estimate the true average score of all students to be between 74.9 and 81.1. Hypothesis testing starts with two statements. Null hypothesis, H0, the status quo. Alternative hypothesis, H1, what we want to test. We then use our sample data to decide whether to reject H0 or fail to reject H0. Notice, we never say accept H0. We only say reject or fail to reject based on evidence. Imagine a company claims their batteries last 10 hours on average. We take a sample of 35 batteries and find the mean is 9.4 hours. We run a hypothesis test. H0, M Baracus 10, H1, M 10. If the p-value is 0.012 and our significance level is a was 0.05, we reject the null hypothesis because 0.02, 0.05. This means the sample provides enough evidence that the average battery life is not 10 hours. These two topics are deeply connected. If a confidence interval for M does not contain the hypothesized value from H0, we would reject the null hypothesis. For example, if H0 says M tau is 10 and our CI is 8.9, 9.7, 10 is not inside, so we reject H0. Both methods lead to the same conclusion. Here are mistakes I see all the time. 1. Thinking 95% CI means there is a 95% chance the mean is inside. 2. Forgetting to identify H0 and H1 correctly. 3. Misinterpreting p-values. 4. Saying accept H0 instead of fail to reject H0. 5. Using Z when the sample size is small and S is unknown. To summarize, confidence intervals estimate population parameters. Hypothesis tests evaluate claims about populations. Both rely on sample statistics and probability. Both methods should tell a consistent story. Understanding these concepts strengthens your statistical thinking and your ability to make data-driven decisions. If this lesson helped you, hit like, subscribe, and share with someone studying statistics.